Yeah. So in this video, we will discuss about the limitations of first law of thermodynamics and second law of thermodynamics. The first law of thermodynamics states that heat and work are mutually convertible. It means we can convert heat into work and work into heat. They are mutually convertible. In other words, we can say it is the conservation of energy. That is, every process is possible provided energy is neither created nor destroyed. So, first law says that energy can be converted into one form to another form. Condition is that energy is neither created nor destroyed. So, if this condition is satisfied, every process is possible. The first law places no restrictions on the direction of flow of heat and work. It doesn't say about the direction, which conversion is possible fully. So, according to first law, in every cyclic process, work is completely converted into heat or heat is completely converted into work. Means we can convert work completely 100% into heat, and heat can also be converted fully into work. Potential energy can be transformed into kinetic energy, or kinetic energy can be transformed into potential energy. Heat flows from hot body to cold body, or from cold body to hot body. The gas expansion may be from high pressure to low pressure and from low pressure to high pressure. It is as per the first law of thermodynamics. But from experience, it is not true at all. We know that this is not true. In natural way, as we know that heat is not completely converted into work, because when we convert heat into work, some loss of the heat will occur. Amount of heat cannot be fully converted into work. But the reverse is true. Work can be fully converted into heat. Potential energy is converted into kinetic energy. But reverse is also not true here also. If we can convert 100% potential energy into kinetic energy. But kinetic energy cannot be fully converted into potential energy. And you also know that heat flows from hot to cold body. But the reverse is not true automatically, because heat flows, we are having the two bodies. One is the hotter body and there is the colder body. And definitely the heat will flow from the hotter body to colder body. But the heat cannot flow automatically from colder body to hotter body, because it will require some amount of external work. The spontaneous process can be reversed, but all they will not be reversed automatically. They require some external force to reverse it. Here we can consider the two reservoirs which are at temperature T1 and temperature T2. The one is the reservoir A and the reservoir B. Now T1 here is greater than T2. So definitely the heat will be transferred from reservoir A to reservoir B. First law says the heat can also be transferred from B to A, where the T2 is where the B reservoir is at the lower temperature T2. So, according to first law, it is possible that a heat can be transferred from a higher temperature body to a lower temperature body, and also from lower temperature body to a higher temperature body. Okay. Similarly, if a system which is getting W122 amount of heat from the surrounding, and it is also giving the surrounding the Q221 amount of heat, the energy. So here W122 is equal to Q221, means whatever amount of energy is given to the system, then the system is converting work energy into heat energy. So it is okay. It can be done because the work is a higher grade of energy. But according to first law, it is also possible that if we are giving Q122 amount of energy to the system, then it is also producing W221 amount of the energy. So here it is possible only if the Q122 is greater than 221, means the larger amount of energy is supplied to a system, then it can produce only W2 to one amount of the work. Some heat losses will be there. It is practical possible. Okay. So we can say for a cyclic process, W equal to Q, and it is, but Q equal to W is not possible. In that case, the Q should be greater than the W. Here the arrow indicates the direction of the energy transformation. So it is said that work is the high, said to be the high grade of energy, and heat is the low grade of energy. The complete conversion of low grade energy into high grade energy in a cyclic process is impossible. We cannot fully convert the high grade energy and the low grade energy, that is the heat, into the high grade energy, that is the work, fully. Okay. So the any particular process under consideration is possible or not. In other words, we can say that first law is necessary but not a sufficient condition. First law is necessary, it is required, but it is not a condition, because it has given the concept or the base to develop on the second law of thermodynamics. It is necessary, but uh, it is not sufficient. Second law of thermodynamics may be defined, I would say, that heat cannot itself flow from a cold body to a hotter body, and it can flow only when some external work is required, supplied to it. For example, in refrigerator system, as you know that our refrigerator and air conditioner system, they are working in which there is a heat flow, and this heat flow occurs from the low temperature region or low temperature body to higher temperature body. But to run the refrigerator or air conditioner, it requires some extra amount of energy. If we do not give that amount of energy, it is not possible to run our refrigerator. It cannot transfer heat from low temperature to high temperature. So first law is necessary, but it is not sufficient, because it doesn't say about the direction of energy in which it is practically possible. These were the some of the drawbacks of first law of thermodynamics. Thanks.